Hey, Dr. Clark coming at you with a Check Your Understanding video. Section 7.3, we're in Laplace Transforms. The question says to use the method of Laplace Transform to solve the following initial value problem. So they've given us a second order, homogeneous differential equation with initial conditions. All right, so we're going to use the Laplace Transform to solve this. So the first thing we're going to do is we're going to Laplace the entire differential equation, L of y double prime plus 8y prime plus 25y equals L of 0. We'll use the linearity of the Laplace to separate out these terms. And we will use the fact that the integral of 0 is 0, and therefore the Laplace transform of 0 is 0. Then we will use one of the properties of the Laplace transform that says L of y prime is SL of y minus y of 0. And therefore, L of y double prime will become SL of y prime minus y prime of 0. Then we'll have 8 times L of y prime will become SL of y minus y of 0. And then plus 25 L of y equals 0. Now we know the initial conditions, y of 0 and y prime of 0. Those are given to us here and here. Okay? But this also has to be Laplaced one more time. So let's start working our way down. So we have S times L of y prime, which is going to be itself SL of y minus y of 0. Now we have this term, minus y prime of 0. Y prime of 0 is negative 12, so if we subtract negative 12, we're actually adding 12. And then I guess we can multiply this out. Plus 8s L of y. This y of 0 is 3, so negative 3 times 8 would be negative 24. So minus 24 plus 25 L of y equals 0. And if we collect all of the L of y terms, we will have an s squared from right here. We will have an 8s from right here, and we'll have a 25 from right here. So that's s squared plus 8s plus 25. And that is, of course, the characteristic equation from the original differential equation right there. And then we have a y of 0, which was 3. And that's negative 3 times s. So we have a negative 3s. Negative 3s minus 12. If we combine negative 24 with positive 12, we get negative 12. And that is now set equal to 0. And therefore, we have L of y. Right-hand side will be adding 3s plus 12. And then we can add this to the right-hand side, and then we can divide this underneath it. So that's 3s plus 12 divided by s squared plus 8s plus 25. All right. Now, this problem here is not itself on the Laplace transform formula sheet. It's an irreducible quadratic. So the denominator, we sort of have to work out into a, well, let's see, we got 8 here. Half of 8 is 4, right? So this is s plus 4 squared. If I do s plus 4 squared, that would be equal to s squared plus 8s plus 16. And 16 plus 9 is 25. So this s plus 4 squared uses up s squared plus 8s plus 16 of this, which is everything except for 16 plus 9 is 25, so everything but the 9. So we're going to have a plus 3, or plus 9 rather, here. And the numerator can factor into 3s plus 4. And so now this is looking like the kind of thing that we can solve using the first translation theorem. And the first translation theorem says this thing here really looks like 3 times s over s squared plus 9. And if we had 3, if we really did have 3 times s over s squared plus 9, then the solution would be 3 times cosine of 3t, because 9 is, of course, 3 squared. And cosine has the s right there. But because we have this s into s plus 4 shift, then we have to multiply that by e to the minus 4t. And therefore, our solution to the problem is this y of t right there. And if you think about that with the initial conditions, the initial position was supposed to equal 3. Well, if I plug in 0, cosine of 0 is 1, that'll give me the 3, e to the 0 is 1, so the initial position is 3. And if I take the derivative of this and then plug in 0, I will get this negative 4 will come down. Negative 4 times 3 is negative 12 from the derivative, and I will get a negative 12 as my initial velocity. So this problem is illustrating a couple things. Number one, how to use Laplace transform on a second order, and then how to take the denominator, especially when you have a friction term here. But this is underdamped, right? So you should think underdamped, we're going to get sines and cosines here. How to take the denominator and rewrite it as that quadratic term, take the numerator and factor it so the shift is matched, numerator to denominator, and then decompose this here into the basic part, which is 3 cosine of 3t, and the shift, which gives you the e to the minus 4t. All right, so give yourself a score between 1 and 4. Hopefully you're giving yourself a 4. Do some reflection. What do you need to do to learn these things? What's making sense? What's not making sense? I'm going to give myself a 4, and we'll see you next time.